This segment is brought to you by Audible Learning Technologies. ALT is the leader in Audible geology educational resources. In this segment, we will be discussing map and cross-section interpretation as it pertains to age relationships. The relative ages of units may be established by using fundamentals or simple geology principles. There are 7 basic principles that may be used. First is the law of initial horizontality. Second is the law of superposition. Third are cross-cutting relationships. Fourth is lateral continuity. 5 is floral and fauna succession. 6 is the law of inclusions. And 7 are metamorphic relationships. The law of initial horizontality assumes that the sequence that layers are in were deposited originally horizontally or nearly so. The oldest layer is therefore on the bottom, with the youngest layer towards the top. The law of superposition states that the older layers are on the bottom and the younger layers are on top. This assumes that the layers have not been overturned during deformation. If the beds are overturned or vertical, the stratigraphic succession cannot be determined unless the absolute ages of the units are known. Another way to look at the law of superposition is that beds become younger in the direction of dip. Conversely, if the stratigraphic succession is known, it is possible to use the dip direction to determine the direction in which the units become younger. The law of superposition applies to any layered rock sequence such as sedimentary units or extrusive igneous rocks. Cross-cutting relationships. Cross-cutting relationships can be very useful in determining the ages because cross-cutting is so common. If cross-cutting relationships exist, the feature that is cut is older than the feature that is cut into. Rocks are able to be cut by intrusions, unconformities, replacement of minerals, or faulting. For instance, an intrusive igneous body is younger than the country rock. Another example is that a vein is younger than the rock that it cuts. The principle of lateral continuity. The principle of lateral continuity implies that there are sedimentary layers that, when deposited, cover a large area extending laterally in all directions. Rocks would thus be considered to be laterally continuous, even though there may be separation by uplift or erosion. These rocks could show minor variations in grain size composition due to the lateral variation found from different characteristics of the depositional environment. Floral and fauna. Floral and fauna. Evolutionary changes may be determined from the position of the fossil in the stratigraphic sequence. When one looks at the evolutionary development of fossils, a sequence of ages can be developed. Older and more primitive fossils are usually found below younger fossils. Extinctions may break apart the pattern and new patterns may emerge. The fossil may show direct evolutionary trends, which may be used to correlate with stratigraphic sequences in other areas. The law of inclusions. The law of inclusions states that inclusions in a rock signify that the inclusions are older than the rocks in which they are included. Inclusions may also provide clues of the provenance at the time of formation. And we end with metamorphosed beds. And we conclude with metamorphosed beds. Metamorphosed beds are younger than the rock as it existed before metamorphism.